Hello again on my channel. We've finally reached the US space project Mercury, as announced in the title of this series. We will be examining it in the same order as the Soviet Vostok program, namely, launch vehicle, spacecraft, astronauts, and missions. So, 4 launch vehicles were used in the Mercury project. 2 of them were quite low-powered. These are the so-called Little Joe and Big Joe. They were not intended for putting spacecraft into orbit and were used to test individual components. In particular, Big Joe was used to test the heat shield. 8 launches were conducted with Little Joe to test the Launch Escape System, or LES, which allowed astronauts to escape in case of a launch failure. A good and useful system, no doubt. We had it later only on the Soyuz spacecraft. However, for some mysterious reason, after appearing in the Project Mercury, the LES disappeared on the Gemini spacecraft and reappeared only on the Apollos. The other 2 launch vehicles are already familiar to us. They are the Redstone by Wernher von Braun, standing 21 meters tall, with a launch mass of just under 30 tons and a thrust of 35 tons. It was used for all suborbital missions. 6 launches were conducted, 5 of which were successful. And finally, the Atlas rocket, standing 25 meters tall, with a launch mass of 116 to 118 tons and a total engine thrust of about 162 tons. In percentage terms, the thrust margin was about the same as on the Soviet R-7, around 30%. In absolute terms, of course, it was slightly less, about 40 tons. All orbital missions were carried out using Atlas. 9 launches were conducted, 7 of which were successful. Here, it is necessary to touch on US launch success rate. In the Soviet Union, engineers and designers strove to test components and assemblies as much as possible in full-scale flights. Accordingly, if any component or system did not work or did not operate as intended, the entire mission was considered partially or completely unsuccessful. In the USA, things were somewhat the opposite. First, due to strict cost-saving measures, everything that could be tested on the ground was tested on the ground. That is, if it was possible to do without a space launch, then they didn't launch. If testing a particular component or system required a full-scale flight, then that flight was conducted. And if the component or system being tested performed as expected, the entire flight was considered fully or partially successful, regardless of how well other components and systems performed. Such a peculiar way of keeping statistics. Moreover, the Americans often used refurbished components to save money. For example, during the launch of Mercury Atlas III, the Launch Escape System activated at the 40-second mark. The rocket exploded. The Mercury capsule was ejected, repaired, and then reused for Mercury Atlas IV. This was also an unmanned test flight, but still. In the Soviet Union, safety was never compromised, and such practices were not followed. Any components that did not perform as expected were thoroughly studied, refined, and corrected. However, for each new flight, a newly manufactured component was always used. Now that we've covered the launch vehicles, let's move on to the Mercury spacecraft itself. A total of 20 units were produced. 2 were destroyed during testing, and 5 were never used. The spacecraft was a truncated cone, 3.3 meters long, with a maximum diameter of 1.8 meters and a mass of 1350 to 1,400 kilograms, making it more than 3 times lighter than the Soviet Vostok spacecraft. The truncated cone shape was chosen for several reasons, including weight savings. American designers aimed to reduce the mass of the heat shield. According to their calculations, such a spacecraft, due to offsetting its center of gravity, should re-enter the atmosphere facing heat shield first. Consequently, the convex base would bear the main heating, so the heat shielding was placed only there. A heat shield weighing 387 kilograms was installed at the base. In comparison, the Soviet Vostok spacecraft had heat shielding weighing up to 1.5 tons. According to American engineers, the walls of the spacecraft should only heat up to 700 degrees Celsius at most, so they were not covered with any heat shielding. The spacecraft had a framework, similar to the ancient ironclads of the late 19th century. Onto this framework, with bolts and rivets, exactly, 2 skins were attached. The inner skin was titanium, and the outer one was made of an alloy, the composition of which is still debated. Some sources state that it was made of a certain nickel alloy, Rene 41, while others claim it was made of beryllium. This is quite strange, because if the Americans were saving on mass, nickel is a rather heavy metal. Beryllium, on the other hand, is very light, 1.5 times lighter than aluminum, but quite toxic to humans. This metal is light gray, about the same color as aluminum. Let's remember this. It will be useful later. So, these 2 skins were attached, once again, with bolts and rivets. Their thickness is unknown, but in any case, it was minimal. Saving on wall thickness was also possible because the Americans, as we know, breathed pure oxygen in their spacecraft at a pressure of 0.3 atmospheres. Consequently, the internal pressure on the walls was less than in Soviet spacecraft, where cosmonauts breathed regular air at a pressure of 1 atmosphere. Because of this, the craft's walls were thinner. In other words, strict weight savings were implemented to cram the craft's mass into the specified 1,400 kilograms. This was the payload capacity of the Redstone and Atlas rockets at that time. Next, let's move directly to the design. At the back, directly to the heat shield, the retro rockets were attached with metal straps. This also raises questions among some specialists, because logically, the retro rockets should be located either in the nose of the capsule or on its walls. However, we do not see any engines there. The engines are positioned at a slight angle and were supposed to fire sequentially, giving the spacecraft rotation. Due to this rotation, the craft was supposed to turn 180 degrees in orbit and re-enter the atmosphere with the base forward, as I mentioned earlier. However, if the retro rockets did not work properly or did not fire at all, the Americans had a plan B. This involved a flap extending from the nose of the spacecraft. In shape, it resembled a semicircle and looked most like a lid from a tank or a bucket, which, when extended, created additional drag. And due to this drag, the spacecraft should have turned 180 degrees. Engineers and specialists who will watch this video, correct me if I'm wrong, but as we know, there is no air in space, so any flaps are useless and do not work there. If you deploy such a flap in the dense atmosphere at a speed of 7 kilometers per second, it might simply be torn off or cause the spacecraft to spin uncontrollably. However, the Americans did not provide any other options except for a 180-degree turn and entering the atmosphere bottom first. Again, on all other spacecraft that have definitely flown in space, whether they are our Vostok, Voskhod, Soyuz, or modern American spacecraft like the Dragon or the Apollo, we don't see any flaps or similar devices used anywhere. Only on the Mercury spacecraft do we encounter such a strange feature. Next was the heat shield itself. The retro rockets were supposed to jettison after completing their work, and between the heat shield and the rear wall of the spacecraft, there was supposed to be some sort of skirt that deployed upon splashdown. The process looked as follows. Before landing on water, the heat shield detached and dropped 4 feet. Between the heat shield and the bottom of the spacecraft, the landing skirt deployed, creating a kind of cushion or air pocket that first softened the impact with the water, and second, served as an additional float while the capsule bobbed on the waves awaiting rescue. This skirt was reportedly made of either rubber, fiberglass, or rubberized fiberglass, according to various sources. This discrepancy in its construction is likely due to the fact that no one has seen this skirt up close. In the museums where the Mercury capsules are displayed, either the capsules themselves or the capsules with the heat shield are presented, but the landing skirts are nowhere to be seen. Therefore, it's impossible to look at it closely or touch it. It is only visible in film footage of the capsule being recovered from the water by helicopters, and it's seen from a distance. Moreover, due to the water running off, it's impossible to say for sure how airtight it was and how much it actually improved the buoyancy of the capsule. Again, specialists have questions about what was supposed to happen to the rubber or rubberized fiberglass that came into contact with the heat shield heated to 5,000 or 7,000 degrees. The answers to these questions, as often happens, have not yet been found. Between the heat shield and the rear wall of the spacecraft, according to some cutaways, there were peroxide tanks. I say, according to some cutaways because their location varies in different diagrams. In some, they are located there, between the shield and the rear wall. In others, they are in the nose of the spacecraft. Next was the rear wall of the spacecraft and the crew compartment itself, which contained the pilot's seat, closely adjacent to this wall. The cabin volume was 1.7 cubic meters, roughly the same as the Vostok spacecraft, but there was significantly less space. This is because, as we remember, the Vostok spacecraft had minimal instruments since the entire flight was controlled by automation. However, in the Mercury spacecraft, the cabin was chock full of instruments and equipment. This is explained by 2 reasons. First, we are told that the Mercury spacecraft had more manual control. Second, the American astronauts, being pilots, asked the engineers to make the spacecraft cabin as similar as possible to a fighter jet cockpit. Therefore, there were over 120 different sensors, switches, toggles, buttons, and so on, which, of course, significantly reduced the useful volume. Furthermore, in the narrow end of the spacecraft, there were 3 containers for the parachutes, a drogue, and 2 main chutes, a primary and reserve. Again, some specialists question what might happen to the chutes, given their close proximity to the spacecraft wall, which heats up to 700 degrees Celsius. Let's compare this with the parachute compartments of the Vostok or Soyuz spacecraft. There, the parachute compartment is covered with thick hatches with heat shielding, meaning the parachute compartment is covered and protected just like the rest of the spacecraft. Here, the silk parachutes are stored simply in buckets, tanks with thin metal walls adjacent to the spacecraft's skin. Additionally, in the side of the spacecraft, in the wall, there is an explosive escape hatch secured by 70 bolts. To detonate the explosive charge and blow open the hatch, a manual abort handle had to be pressed. The handle was within easy reach, approximately under the left elbow, and was practically unprotected from accidental activation, which is exactly what happened with Virgil Grissom. After splashdown, while bobbing on the waves waiting for rescuers and logging the panel data, he allegedly pressed it accidentally. The hatch blew open, and the capsule began taking on water. However, Grissom had enough time, courage, and composure to calmly exit the flooding capsule in a depressurized suit without a helmet, get onto an inflatable raft, and wait calmly for the rescuers to arrive. Meanwhile, the capsule sank to the ocean floor and was recovered only 38 years later. In the nose of the spacecraft was the second escape hatch. However, to use it, the astronaut had to perform a kind of acrobatic maneuver. He had to move the instrument panel aside, somehow deal with the periscope located directly between his legs, crawl forward feet first, use his feet to push out the empty tanks from the deployed parachutes, return to the cabin, turn around, and exit through this small, narrow hatch head first. We cannot find any images or video footage where we can fully see the process of an astronaut exiting this hatch during training or actual recovery. There are a few photos showing astronauts already halfway out of this hatch. However, it is impossible to assess whether an astronaut, while in a spacesuit, could fit through this hatch, and if his shoulders would fit through it. Nonetheless, the Americans insist that this was possible. In general, the spacecraft was so small and cramped that the astronauts joked that they didn't get into the craft, they put it on. Now let's return to the spacecraft's outer skin. Not only was it fastened with bolts and rivets with patches and additional plates, but it was also ribbed and corrugated. Moreover, these ribs were applied perpendicularly to the direction of the spacecraft's movement. We are told that this corrugation was specifically designed to slow down the spacecraft during re-entry. However, it should be noted that Mercury's spacecraft passed through the atmosphere twice. Due to weight savings, the Mercury spacecraft did not have a fairing that would be jettisoned after reaching space. It was simply placed on top of the launch vehicle and launched into space, passing through the atmosphere once on the way up, and a second time on the way back during re-entry. Accordingly, during launch, such transverse corrugation would instead take away additional engine thrust, and more importantly, it would cause increased vibrations, which could likely lead to the detachment of the outer skin and the destruction of the entire spacecraft. However, as always, everything worked as expected, and there were no accidents related to the skin separation and the destruction of Mercury spacecraft. Next, regarding the color of the spacecraft. As we can see, the color of the spacecraft did not change. They were black before launch and remained black when they splashed down in the ocean. However, as we mentioned earlier, if their outer skin was made of beryllium, and beryllium is a light gray metal, then the spacecraft must have been painted black. However, we do not see any traces of scorching, burning, or any thermal impact on the surface of these spacecraft. Moreover, all the inscriptions on them remained intact. Let's assume that two of these inscriptions, namely the American flag and the words United States, were applied with some kind of super paint resistant to heating, and that they were applied together with a black coating in a factory method and could withstand heating up to the declared 700 degrees. But each spacecraft also had another inscription. Each spacecraft had its own name. The spacecraft were named Freedom, Liberty Bell, Friendship, Aurora, Sigma, and Faith, all ending with a number 7. The 7 commemorated the 7 astronauts in the first group, which consisted of 7 people, as they called themselves, the Magnificent Seven. This inscription, the mission call sign, was sprayed at the last moment by a female artist from NASA using a template and an aerosol can. However, as we can see, this inscription, made with white paint, was practically unaffected by the double passage through the atmosphere. So, this must have been super paint. That's about all for today regarding the Mercury spacecraft and launch vehicles. In the next episode, we will talk about those brave American guys from the Magnificent Seven who flew on these bolt buckets held in one piece by rivets. We will talk about them, get to know them better, and look at the Mercury missions. That's all for today. See you in the next episodes.